Hey guys, it's like 5:30. I still haven't left work, but I figured I'd go ahead and make this video so I don't forget or get distracted by my children, which I love. So I'm going to make this very quick. So let's go ahead and get started. Again, if you're watching this on replay, you make sure that you're listening for the mystery word. And all right, let's get started. So when I look at this question, it says, study how the example shows place value patterns, then solve. So we've talked about the patterns, and just as a quick review, we said that when I am multiplying by a whole number, or number greater than 1, my number is becoming bigger, and when we're multiplying by a number less than 1, such as 1/10, it's going to become smaller. And so we've talked about place value and how each time you're moving the decimal, whether it's to the left getting smaller or to the right getting bigger, the rule is 10 times. I'm becoming 10 times bigger, or 1/10 of. So here you can see that they have one whole, and then they take that whole and they're dividing it by, they're taking one whole and they're dividing it into tenths. So 1/10 is a tenth of a whole, or 1/10 times 10 gives you the whole. So you can look at it either way. Anyways, I'm going to get right into your examples in the interest of your time as well as mine. So number 1 says, use the times 10 pattern for the example to complete each question. So if I take the number 1 and I'm multiplying it and making 10 times greater, that's basically saying 1 times 10. So 1 times 10. Again, you want to think, I'm going to move that decimal over one place value. Now I have the number 10. 1 times 10 is 10. That's pretty simple. So I also could think, what did I multiply by 10 to get the number 1? So I know that when I'm multiplying by a whole, this is the bigger number, then this is the this is the smaller number. So I'm actually going to take that number 1, and on a whole number, where's my decimal? Right, on the whole number, it's at the end, like I have $1.00. But we drop the decimal if there's nothing there. So again, this is my answer, and it got bigger because I multiplied by 10, which means I started with a smaller number. So I'm going to move my decimal over one place value. And now I'm going to put a 0 in front to hold that ones place. So I have 0 and 1/10, which would be looking cleanly written as that. I took 0 and 1/10. When I multiplied it by 10, it became one whole. Again, I multiplied 1/10 by a whole number. It got bigger. Boom. Now in this instance, we're going to multiply a number by 10. And again, anytime we multiply by 10, it's getting bigger. So even though it's a decimal, it's still, this is still bigger than your original number because I multiplied by 10. I multiplied by a whole number. So I'm going to go ahead and put that in. And I really should be doing pencil because it would just look so much better. I'm going to switch. I didn't realize I had one. All right, so I have 0 and 1/10. That's my final product. When I multiplied, hey girl, hey! When I multiplied by this number, I got this bigger number, which means the original number had to be bigger or smaller. Right? If I multiply by 10 to get a larger number, that means the original number had to be smaller. And since I'm multiplying by 10, that's one place value. So the decimal is going to move. No, I have one person who's invisible, meaning they can't be seen because they have privacy settings. So when I moved it from 1/10 and I knew I had to start with a smaller number, that means that the original number was 1/100th. So now my decimal is moved forward. So whoops, I put a 0 there. That was supposed to be a 1. So when I multiply 1/100th times 10, I get 1/10. Boom. Okay, so let's look at number 2. The pattern can also be helped by describing using division. The grids are examples to complete the equations. So I have 10 and I'm dividing it by 10. So since I'm dividing, I'm getting smaller, or that could be the reciprocal. It could also be 10 times 1/10, because 10 times 1 would give you 10 tenths, which would be one whole. Anywho, you can just think multiply the reciprocal, which means it's going to get one place value smaller. Or divide by 10, again, same thing. I have my decimal here on my whole number, and I'm going to move it over one place value to get smaller because I'm cutting it into pieces. And now it's going to be between the 1 and the 0. So my new number kind of looks like this, except for something's a little bit wrong with it. And that is that when I have a whole number and there's a decimal and there's nothing after the decimal, or zeros, you drop the decimal, you drop the zero. Create that equivalent number. Okay, same thing here. I have the number 1, and they put 0.0, but you need to recognize that you're going to drop that. They did that as scaffolding for you guys to understand how to move it. So this is the number, and I'm dividing it by 10. So I'm taking this $1 and I'm sharing it with 10 friends, right? Which means it's going to get smaller. So now my decimal is here. And now I'm going to put a 0 in front. 0 and 1/10, or 0 and 10 hundredths. Now we talked about how we're going to drop that 0 because we can create that equivalent fraction. So 0 and 1/10. It was 1. When I cut it into 10 pieces, now I have 1/10 of. And same thing here. I'm taking now that 1/10 and I'm dividing it into 10 pieces. So again, because I'm dividing, it's got to get... Sorry, it's cut out on me. There's not good reception here. They must have like interesting Wi-Fi. But anyways, and when I'm dividing, it's getting one place value smaller. And I know one place value because it's only 10 times, or 1/10 of. Saying divide by 10 is the same thing as saying 1/10 of, 1/10 of. Same difference. Okay, same thing. Hey girl, hey! Glad you're on. So this one says use the divide by 10 pattern to fill in the blanks. So each time I move over one place value, my original number is going to become 10 times less because I'm dividing, which is the same thing as saying multiplying by 1/10. So if I have 400, that's the number here. I need to first think, where's the decimal on a whole number? Right, it's at the end. So if it's at the end and I'm dividing it into 10, that means I'm moving over one place value. Now my decimal is actually here. So I'm going to get rid of that original decimal. And because I have a decimal with just a 0 after it, it's basically the same thing as 40. I don't say I have $40.00. I just have $40. So I'm going to drop the decimal and I'm going to drop my 0. I got 40. Now if I take my 40, I'm going to write it in lightly so it's easier for me to erase. I take my 40 and I divide it by 10. That means I'm going to get one place value smaller. And if I get one place value smaller, where's the decimal now? Right, it's right after the 4 now, so it's here. And again, when I have a decimal with nothing after it or just a 0 after it, I drop the 0, I drop the decimal. Boom. When 0 is at the end of any decimal, you drop it. It doesn't matter what it is. It could be 2 and 560 thousandths, you would drop the 0. So you always will drop that 0 at the end. So 4. And then you can see here they divided by 10 again into, now they took that decimal that was here and they moved over one place value smaller. And we're going to continue that same pattern, 0 and 4/10. And again, we're going to divide by 10, which is the same thing as saying times 1/10. And I'm going to move over one place value. And now I have this number, but I haven't completely written it correctly. There's one little issue. What's my issue? Right, my issue is that I need to put a 0 there to hold the place value. So I actually have 0 and 4/100ths. Okay, so how are the decimals 9 thousandths? I'm back. It keeps cutting out on me. So THT, tenths, hundredths, thousandths. I have 9 thousandths, and I want to see how that's related to 9 THT, and you see how it's related to 9 hundredths. And so hopefully what you see is that the decimal here has 2 zeros after it, but now it will only have 1 0 after it. So to have 1 0 after it, it had to move over one place value. So I started with a smaller and I went to a bigger. If I start with a smaller and I go to a bigger, I could say that it is how many times greater? Okay, this reception here is driving me nuts. But I could say that 0 and 9 thousandths is 10 times greater, no, I take 0 and 9 thousandths, multiply it by 10, and that would be what gives me 900ths, because I multiplied by a whole number, it got bigger. You could write the reverse of that. You could say not 0 and 900ths times 1/10 is equal to 9 thousandths, because I multiplied by a fraction less than 1, it actually moved over one place value smaller. Boom. So you could do that. There are many other ways that you could say it. I'm not going to go through this with you. I think it's fine. I think you'll be great. Just quickly, as some reminders, choose yes or no, which means you're going to go through all of these and just think about the place value. You want it to be equivalent to this. You want it to be equal to that. And if you multiply it by 10 or by whatever it's telling you, multiply, divide, see if it's, yeah, my Wi-Fi is poor too, so I'm about to leave. See if it comes out correct, yes or no. Here, you're just going to take the word form and put it into decimal form. Here, you're going to take the decimal form and put it into word form. Compare, think about strategies based on place value. How do we compare? We always start at the larger digit. And here, you're going to do some shading. For everybody who followed along tonight, your word for tonight is